What is going on, everybody? It is Wednesday, November 16th. It is 4 o'clock and live from the SOS studios in Georgia. This is Streaming on Streaming. How is everybody doing this lovely Wednesday afternoon? My name is Todd Sharp. I am the host of Streaming on Streaming, a live weekly show on the AWS Twitch channel where we talk about all things involving live streaming and building live streaming applications with a very, very focused agenda towards developers, so people who are building live streaming applications. I, as I said, am Todd Sharp. I am the lead developer advocate for Amazon Interactive Video Service. And I run this show, and sometimes we have guests on, sometimes we just kind of dig into some code and look at a specific feature. Sometimes we do fun little projects, but we always have a lot of fun and love interacting with all of you in the chat. So if you're joining us, say hello, let us know where you're from. We love to answer questions as long as we keep everything cool, keep everything clean. Make sure we're not posting anything spam or abusive or insensitive in the chat. So, that all being said, we have a very fun episode today. Today we are actually, speaking of chat, we're going to be focusing on chat. And you're on Twitch. You see a live stream here. To me, live streams without chat are essentially TV shows, right? You're just going to comes to a site and consume the video. You're not going to do any interaction with other viewers. You're not going to interact with the broadcaster at all. You're just going to kind of sit there and consume the content. So chat obviously adds a very different level of interactivity. Unprecedented almost level of interactivity that really no other medium kind of provides. If you go to any other channel on Twitch, a gaming channel or sports channel, any other channel, and you see someone presenting, you see someone broadcasting, you're going to see interaction. You're going to see the host talking, taking questions. The chat essentially directs a lot of time the stream. Maybe not so much on games, but it just provides a different level of interactivity. So we're going to look at Amazon IVS Chat in this stream today. So what is Amazon IVS Chat? Well, Amazon IVS Chat is a feature that we offer, a service that we offer that allows you to add chat to your live streaming applications. I feel like I'm being very redundant today. I guess I kind of am. Let's see how many times I could say chat in the next 5 minutes. Yeah, let's try to not see how many times I could say that. So, IVS Chat. Oh, there we go. IVS Chat is built on WebSockets. And if you're not familiar with WebSockets, let's talk a little bit about what WebSockets are. If you are familiar with WebSockets, put it this way. Are you familiar with WebSockets in the chat? Let me know if you have experience with WebSockets, if you've used them before, if the concept of WebSockets makes sense to you, and if not, let's chat about WebSockets. So WebSockets were created because there was a need for bidirectional communication on the web, right? If you think about a traditional web request, a traditional web request is a request to a server. You type in a URL into your browser, or you go to your command line, you go to open up curl, you make a request to a server. Now there's a lot of things that happen in between your request being sent and a response being delivered, but let's simplify things and let's just say you make a request, the request gets to the web server determines what it is that you're looking for, and it delivers that back to you. And then it closes the connection for the most part. Let's not complicate things and get into HTTP to keep alive, because for the most part, those are very short-lived connections that are kept alive. And they're done to essentially limit the amount of back and forth between the server when you're loading a web page. So if we want to talk really quickly about HTTP to keep alive, what happens is you make a request, the server, let's say you make a TLS request, an HTTPS request. The server, there's some handshaking that goes on that says you are who you say you are, the server is who it says it is. And a keep alive request stays open while additional files are being transferred, right? So it prevents the need for you having to go back and do that handshake again when you need a CSS style sheet, or you need a JavaScript, or you need an image, any of those kind of things. So that's keep alive. We're not talking about keep alive. For the most part, an HTTP request is a request and a response, and then the connection's closed, right? Now WebSockets, you make a request. Actually, before we go into that, a quick analogy. How many of you, like me, grew up in the 80s and you remember self-addressed stamped envelopes? It was kind of a silly concept if you think about it, really. What you would do is you take an envelope and you'd address it to yourself. You'd put Todd Sharp, blah, 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 city, state. You'd put a stamp on it. And you wouldn't seal it. You would leave it unsealed. But you would then fold it, or you wouldn't fold it. You'd just get a larger envelope. And you'd put the envelope in the other envelope. And you'd address it to a charity, or a travel agency, or a nonprofit, or a celebrity. A lot of times you would do this for celebrities if you wanted like an autograph from a celebrity. Back in the day, you could actually send it and request a signature, autograph. So you'd seal up that outer envelope, you'd put a stamp on it, and you'd mail it. And then you'd wait for about a week or 2 weeks, and you'd just kind of wait for a response, right? But then you'd get a response. And so to me, an HTTP request is like a self-addressed stamped envelope, right? You make a request, you get a response. And for those of us who are familiar, or who are more comfortable with modern times, today what you would do is you'd go to a website and you'd download a PDF. Or you'd go to a travel agency website and you'd download a brochure. So I hate to use the term asynchronous, and I won't, because that'll just kind of confuse things, or synchronous. But if you think about asynchronous communication, let's not go there. So WebSockets start off as HTTP, and the browser makes a request to a server, but it includes two special headers. The first header is called an upgrade header, and the value is going to be WebSocket. The second header is called connection, and the value is upgrade. UPGRADE, upgrade. The server receives this HTTP request, standard HTTP request, most likely HTTPS, TLS, secured. But then it says, okay, do I support WebSockets? And the server asks itself this. I'm not sure how servers talk to themselves, but whatever. So the server says, do I support WebSockets? And if it does, if it can say, yes, I support WebSockets, I speak that protocol, it will return a response, a standard, normal HTTP response. And in that response, there will also be the same two headers, the upgrade and connection header. And the status will be, let me look at my notes, 101, which is very different than we're used to seeing. Normally 200 and 400 and 500, 300 redirect, that kind of thing. But a 101, switching protocols. So the HTTP request and response is done. It's complete. But that connection is left open, and both the server and the client both switch protocol to use WebSockets so that connection remains open. So in the self-addressed stamped envelope analogy, if we think about that being a request and a response, you mail something through the postal service, and you get a response eventually. If you want to compare WebSockets to another form of communication, you could think of it like a telephone call. And again, I know another outdated mode of communication that nobody uses these days, but let's say you make a phone call, you pick up your phone, and you dial a number, somebody answers, and you begin to converse. You talk back and forth. Hopefully you wait for one another to finish your sentence before the other one starts speaking, but that connection remains open. And the only time it closes is if something technically goes wrong. If somebody came and cut your wire to your home, well, I guess we don't really use wires anymore, but if the network went down, if there was a outage at the cell tower, the mobile network had an outage, there was a trunk line that got cut, you went into a tunnel, you drove into a tunnel, your call dropped, you lost signal. That's the only time that the call terminates. The connection terminates. With WebSockets, it's the same. The only time that connection terminates is if there's network problems, if your internet goes out, if you're driving, let's say, again, on your mobile device, and you're using a WebSocket connection, you go into a tunnel, you lose signal, you lose your connection. Or one of the parties willingly disconnects. So you close your browser tab, or you hit the log off button. That's the only time that the WebSocket closes. So WebSockets in a nutshell compared to HTTP requests. Hopefully that makes sense. Hopefully that gives you a little bit of understanding if you're new to the concept. Again, feel free. Any questions you have, post them in the chat, and we'll have some fun. So, WebSockets, Amazon IVS chat. Let's actually start building some chat rooms. Let's create a chat room. Let's learn about how to create that through the console, through the SDK, through the CLI maybe. And then we'll get into some more concepts. We'll get into chat tokens. We'll get into creating a chat room, creating a demo, and maybe we'll have time to get into moderation. We'll see how things go. If we run out of time, we may move on to next week and kind of continue this discussion, but we'll see how things go. If you're just joining us, this is Streaming on Streaming. I'm Todd Sharp. Today we are talking about Amazon IVS Chat, and we're going to add a chat room right now. So let's get into it. Amazon IVS Console. If you come into the AWS console, you search for Amazon Interactive Video Service, or you have a nice little bookmark here because it's your favorite service. Come here on the left-hand sidebar, and you have chat. You have overview and rooms. So if you click on overview, you can get a little kind of fancy architecture, how it works overview, get a little bit of marketing, benefits and features, blah, blah, blah. Use cases, stream chat. Amazon IVS Chat is designed for scalable stream chat use cases, provides near real-time, high throughput chat experience without the need to persist messages. Very much appreciated. You're not sharing your screen. Don't know if it was supposed to. Yes, I was, and I forgot to do that. So let's go over there. Appreciate that, Flebron. Flebron, is that right? Flebron. Okay. IVS Console, Interactive Video Service. Click on Chat Overview, and we'll scroll back down. You've got your architecture drawing. You've got the benefits and features marketing, and then you have your use cases. So here's the one we just covered. Frustration-free scale. That's the other nice thing, obviously, about using a managed service. It's the same kind of traditional discussion that you always have when you talk about a managed service, right? Can you roll your own WebSocket server? Absolutely. Is it easy to do? For the most part, it's not too bad. I've built WebSocket servers with Java. I've built them with JavaScript. There's a nice plugin or whatever you call it, middleware for Express that you can use to manage WebSockets. In fact, I have a little application that I'm using during this stream that uses WebSockets locally. And it's a little thing that I built to actually put the little highlighted chat messages on my stream as an overlay. So not difficult to run your own WebSocket server. Is it difficult to do that at scale? I mean, you could argue about this all day. Scaling is never easy. It's in the right hands. It's doable. It's easier. But when you've got something like Amazon Interactive Video Service, this service that powers tons of hours of live video that are streamed on the web, you can kind of be confident that the service, that we know what we're doing. The service has been engineered to scale. You don't have to worry about any kind of outages for the most part. There's, SLAs, you can check those in the docs. But for the most part, it's hassle-free. You don't have to upgrade the OS, manage patches. You don't have to worry about security, securing the server, any of that stuff. It's all handled for you. And the spin up is easy. You just come in here, you go to the console, you go use the SDK, use the CLI, and you're good to go. So let's jump into it. We can click on rooms, and you'll get a list of all your rooms. If you've used the Amazon console before, you're probably familiar with this kind of layout. So what we can do now is click Create Room. And we go into the Create Room, AWS Twitch Stream Chat Room. So we give it a name, and we have very simple options here. We have room configuration, we have a default, and we have a custom. By default, your maximum message length is 500 characters. If you go to custom configuration, you can see that that is the maximum that is allowed. So you can't ever have a message larger than 500 characters. And you can also limit the throughput. You can also limit how many messages get sent per second, values between 0 and 10. I sure hope you would never set this to 0 because that would make your users very unhappy. So the default's 10. The maximum that you can do is 10. So we'll leave it at 10. Scroll down a little bit. We have a section for Message Review Handler. Now this is really cool, and I've blogged about this a few weeks ago, but essentially this is a way to handle chat moderation, right? If we think about chat moderation, there's really two approaches. There is a automated approach and there's a manual approach, right? With automated moderation, you can essentially intercept every message sent to your chat room. And you could do that with a Lambda function. And that Lambda function receives an event. It gets invoked and receives a JSON event. And we'll look at the structure in a little bit, hopefully if we have time. But it receives this JSON event, and that contains all the information about the message ID, the message content, the user ID of the message, of the sender of the message. And you have to create a response. So whatever business logic you have, you can review the content. You can use AI. You can use a allow list of key terms or a deny list of key terms. Do a regex, whatever you need to do. Send a self-addressed stamped envelope to somewhere and request that they review it manually. No, you're not going to do that. But so this is automated chat moderation. You can reply, and whether or not, based on the response, you can either allow or deny the chat message. Now, you can also specify a fallback result because you've got a very short window of time in which to return that result. Does not specify here. It does not specify over here, but I believe, if I'm not mistaken, and we'll have to check the docs on this, I believe it's 200 milliseconds. So your function has to provide a result within 200 milliseconds, or the moderation fails. Now your fallback result is how do you deal with that failure? Whether you want to allow or deny the message if it fails to return a result, or if there's an error, anything like that. So if you want to be really pessimistic, you could deny every failure just to be on the extra safe side. You can do, if there's an error, if there's a timeout, deny everything. If you want to be really optimistic, you can click allow. So if there's a failure, if there's an error, the message goes through anyways. Now, that brings us to the second form of chat moderation, right? And that is manual. Obviously, you have automated with Lambda. You also have manual. And manual moderation is essentially, again, we'll look at this in a bit, but manual moderation is a moderator like myself, for example, during this stream. I see my chat. If I wanted to come over here and delete a message, I could do that. So I'll post a message. Hello, everyone. So I posted a message to the chat. I said, hello, everyone. And if I come over here, and you know what? It won't let me delete my own message. Well, if someone could post a message, and again, please keep it clean, but someone post a throwaway message for me, and I'll kind of give you an example. Hi, can you ban me for 5 minutes? Hamtorito101 says ban me for 5 minutes. I don't want to ban you for 5 minutes, but I can delete your message. And if I click delete, do you want to enable the ability to timeout and ban an embedded version of Twitch chat? No, it's because I'm using the embedded. Let me actually go up to the actual Twitch chat. Let me click delete message, and it's deleted. So you see a message there that says Recursive Co's deleted Hamtorito 101's message. Click to show. Okay. So that's an example of manual chat moderation, right? It's an admin, a human that participates in the chat and can delete or censor if that's what your business rules are. Whatever. I'm not here to tell you what your business rules need to be. I'm just here to tell you how you could do this if you had business rules that said you needed to do it. So that's manual moderation. Now, there's pros and cons to each. There's benefits and drawbacks to each, right? Automated messaging, people are amazing at getting creative to find ways around block lists and allow lists, right? They will use the letter 1 for an I. They will use a lowercase l for a capital I. They will use an @ sign for an A. They will use spaces. They will use underscores. They will use hyphens and hashtags and all kinds of amazing ways to work around your block list and allow list. And there's just no way to stay on top of that. There's always going to be someone that can work around it. There's going to be new words that become offensive or insensitive or unacceptable in new contexts, right? Sometimes people are just amazing at creating new offensive terms. Humanity will never cease to find ways to hurt other humans, unfortunately. So, automated message moderation is not perfect. And that's why your best approach is usually a combination, right? You can catch obvious bad words and you can update your allow list and you can keep that up to date. You can use a third-party library. You can, again though, because you have to keep it within 200 milliseconds, I wouldn't be making any remote calls to any kind of third-party APIs, but you can pull in libraries that, there's one, if we get to it, I'll show you in Node, that is pretty good. So the best approach is a combo approach. Automated, not going to catch everything. And again, context is everything. Tone is a lot of things. So a combination approach, automated and manual. So now that we got that out of the way, let's For now, we'll skip. Actually, while we're here, let's go ahead and do this. We're going to have a fallback result of allow, and we're going to create a Lambda function. So let's do it. Let's create a Lambda function. And it's going to be really, really simple, but it's going to work. So we're going to call this the streaming on streaming chat moderation function. We're going to use node 16, architecture, permissions, advanced settings, all good, create function, right? So we're creating our Lambda for automated chat moderation. This is going to be the most amazing function you've ever seen in your life. No, it's going to be very basic, but it'll illustrate the concept here. So we have a handler here, and what we want to do is we'll delete this, and we're going to return an object. And in that object, if we jump over to the documentation, so this is the request syntax. This is when you get a message sent to your chat room, this is the format, the JSON format of the message that's going to come in. It's going to have a content, message ID, blah, blah, blah. And the request body, here's some details, explains what each of those are. And here's your response syntax. So we have to return content. So whatever the content is, whether we've modified it, whether we've deleted it, whatever it is, we set the content back into the object. Then we have the review result. That's going to be allow or deny in all caps. And then we have attributes. If we want to send a reason for the denial or the deletion, you can send a reason as an attribute. So if we come back here and we want to return, create a return object, and we're going to have a review result of allow. So in this case, let's say we're going to censor, and maybe that's a bad word, but we're going to modify the content of the message that's delivered back to our chat room, right? So we'll say review result allow content. We're going to use event.content, and let's just do let's do an amazing, very complex algorithm. This is a machine learning AI/deep learning/metaverse method. It's called a regex. So we're going to replace the phrase bad word, yes, bad word, with and case insensitive and globally. So if you're not familiar with regex, I is case insensitive, G is global, meaning anywhere in the string, not just at the beginning, not just at the end. And all of them, actually. Global handles all of the instances of it in the string. And we're going to replace that with a modified version of the string bad word. So 3 asterisk space 4 asterisk. Additionally, we need to return, or we can return attributes, as I said, and as we saw in the docs. Did I spell that right? Yes. And attributes is a object, and within that object, we can specify the reason. Because you said bad word. So we're going to actually include the bad word in the reason. No. Auto mod example. So there's our Lambda. We deploy it. We're good to go. We're good to use that in our chat room. If we come back here, SOS, we can now search for and associate our Lambda function. So we got that associated, and we click create room, and our room is done. It's ready. It's good to go. We can start using this immediately. There's our ARN, and I'm actually going to copy that, and just so I remember it, I'm going to set it into actually, I'm going to set it into a environment variable so that we can use that later on. All right, so let me echo that, make sure. Okay, good to go. So we'll clear that. Come back. So we've got a room. We've got a chat room. Chat tokens. We're going to talk about this in just a minute. So we'll skip this for now. But essentially, we're going to talk about it in just a minute, and then I'm going to start talking about it. Essentially, what chat tokens are a way to associate a session, so a user session on the client side, with the chat room. And the reason this is done is because, number one, you can set attributes into a token. So like a username, for example, and a user ID. And those attributes will be available on all the messages delivered from that user, which is nice. Very nice. You don't have to manually send those along yourself. Number two, you have to have a way to associate a session or a client with the messages that are sent, so that if you need to delete a message, if you need to disconnect a user for any reason, you have a way to do that. The API knows how to do that, right? Make sense? Any questions? Okay. So chat tokens. You can generate one for test purposes right here. We'll do that later on. Info about our messaging limits, just a summary of everything we've already done, and our message review handler and the fallback result. So everything's here is good to go and done. If we jump over to our editor, we can actually, before we do that, well, we could do it right from the editor. So to create a chat room, you can also do it with the CLI. And to do that, we just use the IVS chat, and we call create room. We pass it the name. There, of course, is also options for your message review handler, your message limit, all those things. Refer to the CLI docs. So we could do that with the CLI. If we wanted to, we could also create a room with the SDKs, all the various SDKs. So let's take a look at the JavaScript SDK and let us create a chat room. So the first thing we need to do, before we do this is to install the AWS SDK, which if I look at my package.json, we need the AWS SDK client IVS chat. If you're going to be doing any work with IVS, like creating channels, things like that, you need the client IVS. So now that we have the client IVS chat, we can import it into our script here. Create an instance of it. Create an input object. The input object has to have a name. So SOS SDK demo. And let's take a look at the docs. What else can we add here? So create room command, the SDK docs, the create room command input. So all the various options here, we have name, we have message review handler, maximum message length, message rate per second. Let's look at message review handler. So message review handler is a object, and the object has to have a URI and a fallback result. So the URI, currently this must be the ARN of a Lambda function. Is it ARN or is it ARN? I always say ARN, and I've heard people call it ARN though. What do you call it? I don't know how you'd explain that. It's like asking people how to pronounce GIF in text. Of course, it's pronounced GIF. So it has to be the ARN of the Lambda function. So if we wanted to do this, if we wanted to associate the function that we've already, and you can reuse these, of course, you can use a Lambda for multiple rooms if you needed to. So we'll copy that. So message review handler. So we'll say message review handler, and it's an object, and we need to pass the, what did it say? fallback result, and the URI. So fallback result, we'll say allow. I've never tried this, adding a message review handler with the SDK, creating a new room. So this will be interesting. We'll see if that works, if it works. So the ARN, I'm going to call it something different every single time now. And our command, create chat, or is it create room command? Yes, create room command. So create a new create room command. We'll pass it the input. And then our response will be client.send command. And then we'll log the response. So take a quick look at this. We've got our import, we've got our client, our input object containing this chat room name, and our message review handler. I hate how I've used quotes on some of these keys and not on others, so I will correct that so I don't have to keep looking at it. There, that's better. All right, we got our name, message review handler, fallback result, URI, command, response, and log it. Save it, switch to our terminal, and let's see if it runs. All right, nice. So we've got a result. Here's our ARN for our new chat room, our maximum message length and rate per second, our message review handler with the fallback result of allow, and we can see everything looks good here. We jump back to the console, come back to our rooms. We can see SOS SDK demo is there. It's created, all good. And our same Lambda is associated with it. Perfect. So I'm going to go ahead and delete that now because I'm not going to need that. We're going to keep working with the other one since I have already set that ARN into my environment variables. We're going to work with this room. So chat tokens. As I said, you need a chat token every time you make a connection to a chat room that we're going to look at in just a minute. But before we do that, let's see how to create a chat token. Again, you could do that right here. Click this, get a dialog, and you can see the various attributes that are required. We can do that with the SDK as well. So I've already kind of pre-populated something here. So we need an input object here. So we need a user ID. Oops, user ID. This has to be a string, and you will get errors if you do not pass a string. So if we just pass the number, you would get an error. So we need a user ID. And obviously, if you have an application, you have logged in users, you're going to have user IDs, right? You're going to have a way to associate that user. And this is also handy because, as I said, you do receive this in your message review handler, and you can also make it a part of the payload that we send when we manually delete messages. So obviously, if you have a repeat offender, let's say, this is how you essentially build up a ban list or enforce a cooldown period, for example, or permanently ban a user if you have to, if it gets to that. You've got that ID. You can associate that with the person sending the messages, and you can handle that however you need to handle that. So user ID, we also need to specify capabilities. And capabilities are like roles, I guess you could say, just a way to say what the person that owns this token can do. So we have chat token why is that? Why doesn't VS Code like that? Expected, comma expected? Oh, yes, of course. We need to actually, it's an array, not an object. So capabilities is an array, and we can send an array of capabilities. So in this case, to send a message, At your very least, you need a send message capability, and that allows the user to send a message to other users in the chat. You also have a delete message capability and a disconnect user capability. So this is admin type stuff, right? If your user is an admin, and again, in your backend, if you've got a Lambda function or a serverless function or a microservice or a hamster on a wheel on the server somewhere that handles generating this token, you can take that user ID of the user that's requesting the token and determine the proper capabilities to assign to that user. If they're an admin or a moderator, you can assign them delete message and disconnect user. So far, so good. As I said earlier, you can also pass attributes. And these attributes are very nice because they will be associated with this token and sent along with messages in the future. So instead of manually passing the username every single time, you associate this attribute of username with the token, and it's permanently available. Color. For example, if you look at Twitch here in the chat, you have different colors for every username. If you wanted to allow the user to specify their own color that they wanted to use for their username, their own avatar, their own icon, their own emoji, whatever you want to specify, you can pass that all along with attributes and associated with the token. The other thing we need here is a room identifier. I spelled that wrong. Room identifier. Right? Squigglies. Squigglies don't like that because I forgot a comma. Okay, excellent. Room identifier. So in this case, we're going to use that ARN that we saved to my environment variables. And that is the ARN that this token, so that is the room that this token will be generated against. And when we get to the actual implementation of the chat, you'll see that the only thing you really need is a WebSocket URL, and it's the same for every room that you create in a region. So it's the same URL. There's no special differentiator. There's no account ID in that URL. It's just a WSS dot or :// URL. If you're in US East 1, it's the same URL, URI for every single room you create. So how does it know what room to send the messages to, right? Well, it's because you've passed the room identifier with the token, and you're going to pass that token along when you make that connection. So that's how it knows which room to send the messages to. So we'll create the command equals new create chat token command, passing it the input, semicolons forever, response equals await client.send command, and log the response. So fingers crossed, this will run without any issues. And there's our token. So we get a response, we have a session expiration time, and we have a token expiration time. And of course, we have the token itself. So that's the token. Let's talk quickly about the difference between the session expiration time and the token expiration time. So the session expiration time right now is set for 22:45 GMT. And that is 22:45 GMT would be 10:45 GMT. That would be, right? Am I thinking of this right? Yeah, that's 10:45 GMT. Right now it's 4:45 GMT. No, something's wrong here. Because 21:40, so the difference here is essentially when the session expires, when the user can no longer post messages to the room. And if we look back here, at the documentation, I believe it's 3 hours is the timeout. I don't have it handy, but I believe it's 3 hours. We'll refer back to the docs on that one. So the difference is the token expires. In other words, the token has to establish a connection before the timeout. And this by default is 1 minute after the token was generated. So you have 1 minute to establish a connection. So you're going to, most likely this code, that you've used the SDK, this code here is going to be on a serverless function or a backend somewhere. You're going to make a call, you're going to get that token, and it will expire within a minute. Most likely, there's no way you're going to wait longer than a minute, but just be aware you must use the token within 1 minute. So that's how you generate a token on the back end. Let's take a look now at what we do to actually integrate this into an application. So we've got our room created. We could do that with the console. We could do it with the SDK. If you've got a user-generated content platform, most likely going to do that with the SDK. Every time a new user signs up, you'll create an IBS channel for them. You'll create an IBS chat room, store all that good stuff in the database, and move on to actually letting them use that, right? Use the connection, use the channel, use the chat room. So here's the demo that I'm going to run. I've got a DOM content loaded listener, and I'm going to use the good old prompt just because it makes things really easy for this demo. I'm not going to have an SDK. I'm not going to deploy a Lambda. We've only got 10 minutes left anyways. That would take way too long. So I'm not going to make any kind of remote call to get this token. I'm going to do it the old-fashioned way and use the awesome prompt to ask the user when they load the page to paste in a token. You have your chat endpoint, and this comes from several places. If you create it with the SDK, actually, it is not. That's right. It's not included in the reply from the SDK. And I have actually filed a ticket for this to be included with the SDK result. Things are coming back to me now. So it's not included with the SDK. But if we come to the console and we see that the messaging endpoint is here, again, it's the same endpoint for every single chat room in US East 1. So if you've got an application, if you're creating users in US East 1, creating chat rooms in US East 1, you just use this URL for all your different connections. If you're in US West 2, EU West 1, any other region, you would just substitute that region right in here, and everything else remains the same. So come back to our demo. Got that chat endpoint. The first thing we need to do here is initialize a connection. And we do that with new WebSocket. We pass it our chat endpoint, and we pass it the token as the second argument. Now, 10 minutes left. Never mind. Won't go into that. So listen for messages. Let me take a look at my code here and see how I can make this a little shorter than I had intended, because we've kind of gone long on time. So we need to listen for messages. So we want to first, we can add an event listener for message, and that's going to receive an event. The event will contain the message that comes in. So for now, let's console.log it, and we'll see what's inside that message. The other thing we can do here is send messages. So if we listen for the click method on send button, and I've got some markup down here, should have showed you that. I've got a div that contains chat. I've got a text input for a chat message to send, and I've got a button to click to send the message. So we're going to add a click listener for the button, and in that click listener, we'll grab a reference to the chat input, the chat message. and we'll call that chat message element. And we'll grab the value from that for our message. And then we have to construct a payload. And the payload is just an object that contains a few keys. The first key is the action. And hey, Kipolino, is it? Welcome. Thanks for joining. So the first first key in the payload is the action. And the action correlates directly to the capabilities that we had on our token. So if we want to delete a message, we can use this same type of payload and the same API to send a delete message, assuming we have the delete message capability. If we want to disconnect a user, same thing. So we have action and we have content. So content is going to be our message, and that's it. That's our payload. Now we can call connection.send, send the message. And if I've done everything right, which I believe that I have, and we come over to the terminal and we start up an HTTP server, and we open it, and we open the demo, we need a token. So we come back here, and let's open up another terminal here, and we'll create a chat token. So a couple ways, like I said, we looked at how to do it with the SDK. We can go to the console and do it. We can use the CLI. I actually need to change that room ARN so that I create one against the proper room. And actually, that's not going to work because it's not in my local session. So export. All right, let's copy that. Start the server back up. Come back over here. Clear that. Set that. Nope. Set that. Now we can generate a token. All right, so, typo. So we pass a room identifier, our user ID, the capabilities that we want to generate for this token. Again, the attributes, the username. My username is Todd. And then query is just like a JSON-P, I think it's called. It's essentially a way to extract with the AWS CLI, extract one element from the object result. And then I want text output, and then I use pbcopy to copy it to my clipboard. Run that. Of course, I can't do that because I'm not authenticated in that terminal. So back over to here once again. And we will copy that. And we got to do this quick. So we're going to run that. Start the server. Reload the page, paste our token, hit OK, and we're in. So we've got the div, we've got the chat input. We say send a message, click send, and we've got an error. And the reason we have an error is because we tried to send an object in the payload instead of a string. So of course, we need to pass a string, a JSON string, to connection.send on our WebSocket connection. And if we save that, let's see here. I'm gonna, you know what? Let's, oh, fiddlesticks. So, all right, need a token, got a token. Reload the page, paste the token, click OK. Fave icon not found. test, click send. We've got an error again. What's our error? JSON unmarshal. All right. What did we do wrong? We got 4 minutes. Let's see if we can speed debug this. So we're going to, let's log out the payload. Oh, that's why. Okay, I see it. JSON.stringify payload. Not message. All right. One more time. Generate the token. Start the HTTP server. Reload the page. Paste the token. Hit OK. Hit test. And hit send. And there we go. There's our message. So if we look back real quickly, in our message handler, every time we get a new message, we're going to log it to the console. So that's what's happening here. If we had the time, we would certainly append this to the div, make it look nice, add a little delete button for moderation, all that sort of fun stuff. But since we're running low on time, we'll just take a quick look at the message. So if we look at, if I save that as a global, which you should never do, right? And if we JSON.parse temp1.data, this is the actual message itself. So it's got a type of message, and that's going to come into play later on. We'll look at that more going forward. And the content is test. If we open up the sender object, we have attributes username Todd, and that is coming from our token because we set those attributes on our token. We're going to get those every time a new message comes in. We also have that user ID that was also set on the token. Really nice, really handy. Going to help later on. Every message has an ID. If we wanted to delete a message, for example, we would need that ID. So we'll save that into a data attribute when we get to that point. Let's test one more thing. Clear our console. Let's say test bad word and see what happens. So we will again save that as global. temp2.data. And you can see here that our, what's the word I used? Our substitution has taken place. So this message went through the Lambda. That regex that we created over here replaced the string bad word with asterisks. And you can see that happened over here. So that worked. Our Lambda automation worked. 4:59, 1 minute to spare. Tons and tons of stuff yet to get to. So I think what we'll do, if everybody's cool with that, we will probably pick up next week and talk more about chat because there's tons more to go into. Not tons more, but I'd like to show you a little bit more about moderation, show you how to kind of what it looks like to render it to the div, all that kind of fun stuff. Hope you enjoyed this episode. Chat was a little quiet today. Ironically, on a session about chat was a little quiet. That's okay. Very much appreciate you joining me. I will see you next week on Streaming on Streaming.